Welcome to this quickie session entitled The Road to NPM Hell. My name is Paul Watson. I'm a freelance Java developer from the UK based in London. And what I want to talk to you about today is developing projects with more than just a little bit of JavaScript in them. Anytime you have anything more than a trivial bit of JavaScript, me and my team have found a bunch of simple strategies that will help you building your software to be a bit more robust, deterministic, and secure. So earlier in the year, I was at the T point with my fellow developers. This is where group therapy happens for us. We share stories, swap anecdotes, and this one particular time, I was telling a tale of woe about our build. The build server was not in a healthy state. We couldn't do the npm install. It wasn't behaving the same on the build server as it was on our developer machines. We were in a bad place. Pressure was mounting. The project manager was on our backs. Eventually, when we did get it working, the build added a full 15 minutes to the total time of it. This was the inspiration for this talk today. So, unless you've been living under a rock for the last 5 years, you will have noticed the rise of JavaScript. Why am I talking about JavaScript at a Java conference? Because we can't get away from this stuff. It's in the back end, it's in the front end. We've got our ES6 pipelines, React Webpack, linters, concat minifiers, you name it. You want all that exciting stuff in your project, you're going to need a library for that. The main game in town, if you want to pull in a JavaScript library, is npm, the Node Package Manager. If you have a Java background, which I'm sure a lot of you do, Node modules behave in some surprising ways. For instance, they depend on install order. And if you needed any reassurance that npm is the only game in town, I put this classic slide in for your information. The purple line there, going all the way up to 350,000, is the npm line. We can see where's the Maven one there? The Maven's the green guy, going up to about just over 100,000. So when I was writing this talk, I looked at the problems we were having, and I broke them down into 3 key areas: availability, security, and determinism. In 1994, Peter Deutsch and his colleagues at Sun Microsystems drew up a list of false assumptions in distributed computing that we as developers invariably make. The first of which is the network is reliable. We need to remember the network is not reliable. Packets get dropped and switches fail. Which leads me nicely on to security. So, more than 80% of software is third-party libraries. And the JavaScript micro-package approach means that we get a larger attack surface. Plus, I'm sure a lot of you are aware that back in March, there was the left pad issue hit us. One guy unpublished a bunch of his projects, including one of them, which was called left pad, an 11-line beauty that disappeared from the globally namespaced npm.js.org. This left a gaping hole for someone else to put in another left pad, which thankfully wasn't malicious, but a lot of guys were blogging about the security concerns around this, including one I read, a package called Rimrefall, which was an attempt to demonstrate how these things don't even need to be running in production. So, as some of you may be aware, when you run an npm install, it executes arbitrary scripts, or you have the option to execute arbitrary scripts at the end of the install. And this guy demonstrated the classic rm-rf/*, which I highly recommend you do not install. Deterministic builds. So as I mentioned earlier, npm3 and the same with the latest release, npm4, depends on install order. So 2 developers with exactly the same package may not be able to faithfully, package.json, may not be able to faithfully reproduce the dependencies in the same node modules directory depending on when they join the project. So I've painted a pretty grim picture at this point, and what I wanted to go through is some of the practical tips that my team and I employed that other Java developers, when we were in those group therapy sessions around the T-point, those guys were saying, hey, I've got problems with my build server as well. And it seemed like it wasn't just us, and some of the suggestions that we came up with were useful to those guys. Maybe you're already doing some of these, maybe you can find some use in them. Strategy number 1 is run your npm.js.org cache. Essentially, you can use something like Nexus or Artifactory. They both provide really cool features that quite easily allow you to proxy npm.js.org. This has several advantages which I've listed up there. So this means your npm installs are quicker, and it can protect you from outages. It's a big one. So as I mentioned earlier, npm.js.org isn't always guaranteed to be there, and frequently it isn't. And you're guaranteed that when it isn't there, your boss will be wanting you to do that Friday release that is absolutely critical. It's a little bit safer. So if, for example, if you're at a bank and you're working offline, you've got that extra bit of safety there that you're not pulling in transitive dependencies and potentially some malicious left pad script. And finally, kind of the main reason to do it is that you're in control. You get to see what comes into your project. So my team run a Sonatype Nexus cache, and I have one running on this computer here. It just works. Strategy number 2, for all you Gradle guys out there, is standardize your Node.js install. So a lot of our web services are built using Spring Boot and with a Gradle wrapper, and we found the excellent Node plugin, which I've put a little snippet up there of how to include. What this does for us is allows us to standardize Node.js installs. So we're finding developers coming along to us and saying, "Oh, my Node modules are not working. Help me!" And it found that they were running an old version of Node, or something wasn't quite right there over on a Windows machine. It's computable on a Linux machine. So we've got to standardize this stuff as much as possible. What the Node plugin for Gradle allows us to do is to specify a version, in this case 5.3.0, and a disk-based URL, so we can pull it down from our enterprise server. It doesn't need to go out to the web. That then it can install on the build server, and you never have to manually install that on your development machine. This has the advantage that a developer can walk onto the project and straight away do a Gradle build, and it will install Node. And and the advantage of that as well is there's a plugin built on top of that, which is the Gulp plugin, and then you can get that to delegate to your Gulp.js. And in that way, you can run your unit tests, your integration tests, and your Gradle test will then wrap the Gulp.js build and run all your JavaScript unit tests. So it's really nice, like kind of win-win-win. Strategy 3 is fix dependencies. This is a bit of a personal one for me. So semantic versioning is employed in the package.json, which kind of means that your minor and patch versions shouldn't break backwards compatibility, but inevitably things do. So what you can do is run npm shrinkwrap, which is built into npm, and the idea is it will lock in a snapshot in time of your dependencies and write those URLs in there. And then shrink pack. The problem with that is it then misses the cache, so there's shrink pack, which can then zip up your modules and put them on disk. These things are quite, like I've suggested these things here. That's how you would shrink. That was how you'd fix your transitive dependencies. I'm at least suggesting that on our team, we didn't use loosely versions, so no carets and no tildes that were version ranges. Because I don't know about you guys, but we have enough problem with our own bugs without bringing in some stuff. We need to lock down this stuff as much as possible. That's my personal opinion. Venkat was here a couple of years ago, and I remember a thing that he'd said, which was, you're doomed if you do, and you're doomed if you don't. And this is just choosing which way we're doomed. So if we fix our versions, we're at risk of, we're storing up that risk that we cannot bring in more API changes. Whereas if we loosely type our versions, we run the risk of introducing new bugs, and we cannot isolate our problems. Moving swiftly on, strategy number 4, which is get yourself a guard dog. So our team and I hunted around with the security concerns that we had. We hunted around and we found the excellent dependency check tool by OWASP. There's actually a talk in room 4 later on today by Martin LeBlanc called Building Secure Software. I highly recommend you check that out. The dependency check tool, I can quickly show you here. So what I've got in this directory is a simple problemo. How about now? Desktop 4, 1 second. Talk amongst yourselves. Oh, curse the live demo, I'll have to ditch that. So, demo over. So what you would have seen there is that we run the dependency check tool. There is an incubating feature in that. It's a simple command line utility which will recursively look, if you point it at your node modules directory, it will recursively look over it. And wash those package.jsons against the National Vulnerability Database in the US. What you would have seen in that amazing demo was it takes roughly about 5 seconds to go through the node modules directory, and it produces a little HTML report that you can have a look at, and it will say, we found this critical vulnerability in a maybe a transitive dependency that you didn't even know you had. Also ran some like mentionables in this category where we looked around, and there's the SNCC.io and security.io. These actually look really good. For a few dollars a month, they will provide the same kind of software as a service. You just point your tools at it. I think they'll give you a command line thing as well that you can run on your build server. We ended up going with OWASP because it was free and it just worked. So, right. Yarn. So my talk I could have added a few extra things in here, maybe some Docker stuff, only just because it's DevOps and you've got to have a token Docker slide. But 1 month ago, the kind of Hollywood twist in all of this is that the guys at Facebook and Google and a few others were obviously suffering the same problems that the people at the T-point that I was talking with and me and my team were having. So what is Yarn? Yarn is an alternative to the NPM client. It uses npm.js.org, so nothing changes there. It uses the same package.json as you've already got. It even installs stuff in node modules. So all it basically is an alternative to the NPM client that you know and hate. Sorry, love. How is it different? It's fast. I would show you in a demo, but obviously that's nuked. So it's really fast. So it's different from NPM in so much that it pulls down, it does resolution first, and then it pulls down those packages, puts them into a global cache on disk, and then copies them over. It's got separate steps, and because it does that, it can parallelize it, so it's much quicker. It's deterministic as well, which is the biggie. So if you run it on the build server, you're guaranteed, well, as much as you can be, guaranteed that it's going to be the same on your development machines. It auto locks dependencies for you. So the problem with npm shrinkwrap, apart from other stuff, was that you have to remember to get your developers to run it, which is, as we know, like we're a forgetful bunch. It does offline installs, which is really cool as well. So with npm, that was a real struggle if you're on a train or a plane. And people are getting excited because it does checksum verification, but I just can't understand why it wouldn't do that anyway. So to wrap up, some of the things I've been talking about, run a cache, run a proxy using Nexus or Artifactory or the tool of your choice. We have seen how you can standardize the version of Node that your developers install using the Gradle gulp/Node plugin. We can hunt for vulnerabilities in our software using the OWASP dependency check tool, and yarn for the win. Yay. Thank you. I've been Paul Watson. Cheers.